So the first one we're going to talk about is the factor differences of squares. McKenna, can you please read that first paragraph for me?
You have previously learned about the product of the sum and difference of two quantities. Yeah. The resulting product is referred to as the difference of two squares. So the factored form of the difference of squares is called the product of sum and difference of the two quantities.
Okay. That's just a lot of vocab words. That's a lot of he, sees, la, la, la. This is what it's talking about, okay? So it's telling you, if you have something that is in the form like this, okay, we have a squared minus b squared. If we were to factor this out, now we can do the whole factoring, the t-chart thing. However, if it is in this form, this is the shortcut it's giving you. So, for example, if we have x squared minus 25, first thing you notice, x squared is a perfect square, because that means we can multiply x times x to get x squared. 25 is also a perfect square. What can we multiply to get 25? 5 times 5. So if we see something like this where both of these terms are perfect squares, yes, you can do the t-chart and do all of that, but just recognize, if both of these terms are perfect squares, this is the shortcut. X plus 5 times x minus 5. Now we could multiply that out and get the same thing that's written here. So that's just the shortcut. Same thing on this second example. They have t squared minus 64. T squared is a perfect square because we can multiply t times t. 64 is a perfect square because we can multiply 8 times 8. So the shortcut just tells us t plus 8, t minus 8. It does not matter if you write it the opposite way. T minus 8 times t plus 8. You'll get the same answer. Okay? So here's what we're going to write for our examples. We're going to do an example of a difference of square. So let's do 16h squared minus 9a squared. So, first thing we have to notice is this first term. Is this a perfect square? Well, think about it. What can we multiply to get 16? Is 16 a perfect square? Yes, because 4 times 4 gives us 16. So now we look at h squared. Is h squared a perfect square? Yes, because h times h is h squared. So the square root of this first term is 4h. Okay? Now look at the second term. 9. Is 9 a perfect square? Yes, because 3 times 3 gives us 9. Is a perfect square? A squared, I'm sorry. Yes, because you can multiply a times a. So if we multiply 4h squared, we would get that. If we would do 3a squared, we would get that. So these two terms are perfect squares. The shortcut tells us our factors for this is going to be 4h times 4h plus 3a here minus 3a here. That's the shortcut. Now, like I said, yes, you can go through and do the factoring. You can do the t-chart, first term, last term. You can do that. But if you recognize at the beginning, this is a perfect square and this is a perfect square, use the shortcut. That was much easier than going through the box method. This, the square root of 16h squared is 4h times 4h. The square root of 9a squared is 3a times 3a. And then you just use the form, put the plus and minus. Pretty easy. Okay? Don't let it be more complicated than what it is.